Okay, here we have two different gauges. We have a inches of water lift gauge and we have a CFM meter. Now these are two ways of measuring vacuum. Now the debate over which is better, either airflow or inches of water lift, continues. It comes around every so often. Over the past 40 years, we have proven among thousands of other operators that airflow, in other words CFM, becomes king, especially those who are running truck mounts, ETMs, who are going 100, 200 plus feet. It becomes a major element. However, the most important thing is, first of all, when you do a measurement at your end, first you can't have one without the other. In other words, you're going to have both on any system, but the choice is simple. Which one do you want more of? Well, if you're operating, let's say 10 feet, 20 feet, maybe inches of lift. However, when you're going the distance, when you're going 25 feet or more, CFM becomes more important. Now, that's the reason why most vacuum cleaners always go CFM. They always measure airflow because that's what you're picking up. Now you see the meter spinning. That'll spin more as you go further with an ETM. We talk inches of water lift here, we talk CFM here. So we suggest that you take the old way of measuring inches of lift, and let's shelve that, and let's rather talk CFMs. Now, let's focus on our display that we have here. We have two configurations. You see here, the first one is in series. The second one they consider a parallel. I personally consider this particular one independent. Now, let's go back to in series. The in series produces higher inches of lift, but much, much lower CFM or airflow. In other words, here you have two motors, both drawing from one stack. Again, one stack, the air comes in here from your vacuum tank, goes through your first vacuum motor. The hot exhaust goes out here into your second motor, and hotter air is exhausted through the second motor. So you have one inlet and one exhaust right here. What are the problems? Well, the problems are, even though you have higher inches of lift, the cool air goes in one, overheats a second vacuum motor, and when you overheat a second vacuum motor, there's more of a tendency for your amp draw to go high. And you don't want to do that, particularly when you plug in to an outlet in a home. So you want to lower your amp draw, and this will not lower it. The other aspect, bad aspect actually, is if you get any foam, and everybody does, through the first vacuum motor, where does it go? It's going to hit the second one as well. The other aspect is if a vac motor goes out on you, and let's say it's the first vac motor. Now, the only one you have operating is your second one, and you're going to decrease your efficiency because you're going to have to draw through that first vacuum motor. Or if the first vacuum motor is running and the second one goes down, it's the same thing's going to happen. You're going to decrease your efficiency because the other one is exhausting into a motor that's not running. So you get a higher amp draw and you get shorter vacuum life with in series. You have little CFM. Let's move over now to the second configuration, which you consider parallel. Here the advantage is many, and this is what a lot of the ETMs run. You have, in this particular one like we have two stack pipes rather than one over here in series. What's the advantage? It's simple and common sense. You have twice the airflow because you got twice the stack pipes than you do over here with series. All right, so you're going to be drawing in twice the amount of air, number one. Number two is if you get foam, let's say, in one of these vac motors, it's not going through the second one. The other aspect is that you're really drawing true amp draw here. You're not overloading the second vac motor with excessive heat as you do within series. These are running independently of each other, so you're drawing in cool air and exhausting warm air. When you have twice the airflow, what's happening at the other end, 100 feet, 200 feet away with an ETM, is you're drawing twice the amount of airflow through the fibers and up through the nozzle and through your hose. Over here, in series, what happens is that you have inches of water right at the nozzle. But once you get your debris into the nozzle, what happens? It begins to slow down and eventually stops. Because when you're pulling water and debris back 100 feet, 200 feet, it begins to clog the hose and it begins to slow down. Over here, you've got continual airflow. And you also have inches of lift once it gets through the nozzle. So now let's show you by demonstrating with our vacuum and separate those two concepts. Now let's actually demonstrate what this whole conversation and demonstration was all about. CFM and airflow. All right, now what I'm going to do is we have approximately 150 feet of hose on a Jaguar ETM, all right, the MX2. And what I'm going to show you is inches of water lift. Will it lift this bearing? It's a heavy steel bearing. It's 1 3/4 inches. And what I'm going to do is I'm going to put the vacuum hose cuff over that. It's sealed to that floor. And let's turn on the system and see if it lifts that ball through the hose. Go ahead. All right, now we turn the MX2 off. And where's the steel ball? I'll be darned, it's there. I'll be darned. Now, what we're going to do is I want to show you the value of airflow and CFM. That, in fact, it's not lacking inches of lift. You'll always have inches of lift, as I explained earlier. But let's see if it moves that heavy ball. Let's turn the machine on. I'll be darned, it's gone. It's gone. That CFM airflow moves. Now, what we're going to do is I want to demonstrate lifting this heavy workout ball here. Okay, it's 10 pounds. We're going to see if the MX2 will lift that. And again, remember, the MX2 is heavy on CFM and airflow, but when you go 150 feet, 200 feet, with an ETM or truck mount, airflow is important. We'll lift this ball. Let's see. Let's turn the machine on. Again, you can hear the airflow. Let's see if it lifts. I'll be darned. That's called airflow, and that creates great extraction. Now, let's debunk which is more important and what exactly happened here. So we're using the Jaguar MX2, and this is the typical inches of water lift gauge. All right? Now remember, we have a lot of CFMs. Right? We also have inches of water lift. So you're about 136, 37 inches of water lift. Let's use a CFM gauge. So there we are. We're, let's say, an average around 318, 324, somewhere in there. That's CFM airflow. So, in conclusion, we have a choice, and only one choice on any system around. You either run them, you have high inches of water lift and low airflow, so it clogs hoses, or you have extreme airflow and a little bit lower inches of lift. Because again, once you get that water and debris into your vacuum nozzle at the floor, you got to move it. And nothing works better than CFM and airflow in a truck mount.